Hi folks, after 2 years I am back. Again, the topic is debugging classic AVR chips, this time by using the Arduino IDE 2. I have prepared a quick start guide for you and you find it under avr-debug.de. And there you have the things you have to know about how to set up your experiment. The first step is to install the Arduino IDE 2. We assume that we have already done that. Step 2 is, well, we have to install new board definition files. For that, we have to open the preference dialog of the Arduino IDE and paste the following two board manager URLs into the list. So what we have to do is we have to open the preference menu, and then we go into the additional board manager URL, and we have to copy the first URL and paste it in here, and then we copy the second URL and we paste it in here. And then we click OK, say another OK, and now we have the things downloaded. So now we have to install the cores, and first of all we will install the mini core and go to the list of installable things, and we say we want to have the one debug enabled with the highest number, and here we go. Now we have to do the same with the tiny core by Spencer Cont. And again, we will take the one that is debug enabled and we download it. After that, we have to install the DW-Link firmware on our Uno. So how do we do that? Well, we go to the web page of the firmware, and then we choose the latest release and download that. It's a zip file, and here we download it to the downloads directory. And the nice thing about the Mac is that it already has everything set up for you. So we have extracted the zip archive, and we now can look at the thing we want to install, and we will open it with the Arduino IDE. We have to select a board before we can do that. So now we do that. We compile the sketch and then we upload it. So everything worked out. Now the firmware is on our Uno. What do we have to do next? We have to set up our hardware, and that can be very easy. So if you are the proud owner of a DW-Link probe, then you just plug it into the Uno and use an ISP cable to connect it to your target board. If you don't have that, then you might need to set everything up on a breadboard, and you use 6 wires to connect the AT-Tiny to your Uno, and then on the breadboard you also have to put some numbers of discrete components and so on. I have prepared for you this fridging scat and the table of connections, and well, with that you should be able to bring everything up to the point that you can start debugging. So how do we start debugging? Well, we have to load up the sketch we want to debug. Then we have to select the right MCU. In the tools menu, we have to choose the right parameters, in particular the clock. And then we have to set optimize for debugging in the sketch menu. So let's do it. So first of all, we want to open the example sketch, and that has been stored into downloads here, examples, and there we use the warp link sketch. Okay, here we go. And as I said, we have to choose the right MCU, which is the tiny 254585. Now when we go to the tools menu, we have to check whether everything is set up in the right way. And it's indeed an ATtiny85. The clock source should be 1 MHz internal, and everything else is okay. So, well, we may say set the programmer to Arduino as ISP. And in the sketch menu, we have to say optimize for debugging. Now we can try to start debugging, but it tells us, well, before we start debugging, we should verify our sketch, which means we have to compile our sketch actually. So that's what we do now. And now it is happy. And then we can start to debug the sketch. That will start up the GDB server, which will connect to the hardware debugger. And now we are in business. So what we see is now that we have stopped in line 8 in our sketch, and from here on we can debug. On the left side here we see all the debugging panes. The most important one is probably the debug controls over here, where we from left to right we see the potential things what we can do. We can reset the device, we can continue to execute, and when we do that we also can asynchronously stop, and we can step over, which means that we execute until the beginning of the following line, and we can step in, meaning that if there's a function call, we call the function and stop at the beginning of the function. Then there's the step out, meaning that we execute until we reach the point where the current function was called. And then there's the restart, which is similar to resetting the device, which means we start from the beginning. And the stop command, which means we stop debugging and go back to the normal state and can recompile, for example, the sketch. Okay, let's start the program by clicking on continue. So what's happening now? Well, what's happening is that the program executes as it should be without any debugging. And what we can do now, we can stop the program asynchronously here. And that's what's happening here. We stopped in line 520 of the wiring program or library. And okay, so in order to get back to the main program we were programming, we can step out. And well, that means, well, that we finally stop here at the end of the loop function. Okay, let's start now to set breakpoints. Breakpoints mean that the program will stop at this point when we start to execute it. And let's start at the first line of the loop function. And what's happening now? Well, we stopped at the start of the loop function. We can say continue again, and then it takes a while, and we are back at the loop function again. We also can now use the step over control by stepping through the loop function. But what is really interesting now is what's happening to the variable values, right? And that's something you supposedly would see here in the variables pane, but unfortunately you only see here the local variable, but no global variable. It's sort of a bug, I believe, but yeah, what you still can do is you can go into the watch pane and say that you want to see here this byte, the global variable this byte, and maybe also the local variable I. And when we now go back to the beginning of the loop function, we see that we can now watch what's happening to these values, and when we go through the function here, that the values change as well. Okay, I guess we are now at a point where I can leave you to explore the wonderful world of debugging. And if in doubt, refer to the quick start guide and to the DW link manual referenced in this guide. And I hope to see you next time around for another episode on Arduino things. And I click exit here now.